Hello, so we're going to wrap up our unit about chemical reactions and we're going to start getting ready for a test in a couple of days, but this will be our last set of notes and I'm going to try to keep it short and sweet and to the point. So let's get started. We're just going to talk about how we have a couple different classifications for chemical reactions based on what happens. So we've seen the formula is written out and a lot of you have been asking like, so in real life, what is this? And so we're going to watch a Bill Nye video about this and get some real life demonstration and really understand like what's going on with these reactions, because they're not just a bunch of letters and numbers, but they're real things that happen. So some characteristics, two observable characteristics of chemical reaction is that, for one thing, there's a production of new materials with properties that are different from the properties of the reactants. So that means that the products look different, they have different characteristics altogether. So it's proof that there's been a new substance. And we've talked before about the definition of a compound is that it's an entirely different substance from the original elements. There's also a change in energy. So this is what we're focusing in on today. Some reactions absorb energy as they go through the process of either breaking down or putting together different elements. Other types of reactions release energy as they go through their chemical reaction. So one way or identifier about if energy is absorbed or released is to observe change in temperature. So there are two different names for different types of reactions. The first one is called endothermic. The word endothermic literally means the energy goes in. So if you take apart the word, I'm going to put a little line between the O and the T. Endo, the prefix endo means in. And thermic, think about thermal, like if you've ever worn like long johns in the winter, it's also called thermal underwear. It's to kind of trap the heat into your clothes. Also think about a thermos or a thermometer, a thermostat. Those all have the same root word and it's having to do with heat energy. And so these reactions absorb energy in the form of heat. And so that's why it says goes in the little quotation marks there. So it's just a little hint for you. So this reaction is actually going to make the temperature surrounding the object decrease because it's bringing in the energy around it. It's kind of feeding off of its atmosphere that surrounds it. So some examples are the baking soda and vinegar that we mixed up in class. In a couple of classes, I actually had those little balloons that inflated themselves once we smacked it on the table. And the reason that felt cold is because it's an endothermic reaction. It was taking the heat from your hand and using that heat to draw it into itself, and it was powering the reaction through the heat in your hand, and that's why it felt cold to you. Same type of reaction goes on in cold packs used on injuries. You do the same process. You have to break a seal that is separating the different types of chemicals, and then you have to shake it together, and then it's suddenly cold. So there's a chemical reaction taking place on the inside. So there's something called activation energy, and both types of reactions we're talking about today need activation energy to get started. And it's called the activation because it's like the minimum amount that is needed to begin the reaction. So it's kind of like a kickstart. An endothermic reaction needs constant energy from an outside source in order to complete the reaction because the energy is absorbed, and so as it's absorbed, it constantly needs more and more until the reaction is complete. The other type of reaction is called exothermic. So again, we're going to do the same thing as we did with endothermic and look at this. So exo kind of looks like the word exit. They're coming from the same root that means to go out. I think in life science you should have talked about different types of animals, and some types of insects have exoskeletons. The skeleton's like on the outside of their body, so they have like a shell or an armor instead of an endoskeleton, which means the skeleton's on the inside of the body. So you should have seen these prefixes before. So that's just to help you understand what these words mean. Again, we see thermic here to mean heat energy. So based on what the word literally means, it helps us understand what the overall reaction means. It's a reaction which releases the energy. The energy goes out on its own, and this makes the temperature increase. So if I feel it, like it's releasing energy, it's releasing heat onto my skin. So examples would be like burning fuel, a candle flame. You kind of want to touch those things. And exothermic reactions also need the activation energy to get started. So, in order to get the candle to burn, you have to light a match and then ignite the wick with the flame. So it's not just going to start burning on its own. So it needs that activation energy to get started. But because it's got its own energy source and it's releasing energy the entire time instead of absorbing, it doesn't constantly need a supply of outside energy. Basically, that's it. So we just wanted to look at these two different types of reactions and see how they're classified. And we'll discuss more examples of these types of reactions in class, as well as watch a video with Bill Nye. So you enjoy the rest of your evening, and I'll see you later.